Okay, this video here is going to be a quick little introduction to radicals. First off, what is a radical? Well, a radical is any expression that contains a root. And we're going to move, as we're moving along, we'll see exactly what a root is and what that means. But here we have three examples of radicals, all of which contain a root. We have the square root of 36, the cube root of 8,000, and the sixth root of 64. By the end of this little lesson, you should be able to actually simplify all of these. So what is a root? Well, the root of a number x is another number which, when multiplied by itself a given number of times, equals x. That sounds awfully wordy and can be kind of confusing when you read it that way, but if we break it down and show an example, it should become much more clear. So, if we look at the square root of 16 is a number which, when multiplied by itself 2 times, equals 16. Right? The fact that we're saying 2 times here comes from the fact that we're talking about the square root. And we'll show a few examples coming up where we're looking at 3 times and 4 times. But in this case, we want to find a number which, when multiplied by itself 2 times, equals 16. And we can think about that pretty quickly and realize that we're talking about 4. So 4 is a square root of 16. Right? If we erase this guy, do another little example. Okay. What if we're dealing with cube roots? So the cube root of 8 is another number which, when multiplied by itself 3 times, equals 16. Right? So think about that for a moment. Sorry, my mind's kind of wandering, but sorry, this should be 8. Right? The cube root of 8 is another number which, when multiplied by itself 3 times, equals 8. So the cube root of 8 is a number which, multiplied by itself 3 times, is equal to 8. Well, that's going to be 2, seeing as 2 times 2 times 2 is 8. We'll do one more quick example. So we've dealt with square roots, cube roots, now we'll go on to fourth roots. So the fourth root of 16 is another number which, when multiplied by itself 4 times, is equal to 16. Well, so write down, we're trying to find the fourth root of 16. What number, when multiplied by itself 4 times, is equal to 16? Again, it'll be 2. 2 times 2 times 2 times 2 is 16. And we can go on and on with this, and we can look at fifth roots, sixth roots. As you get higher and higher, it obviously gets a little more challenging to pick out what the answer will be, but we could go as high as we wanted to. We could do ninth roots if we chose to. But in this class, we'll be dealing mostly with square roots and cube roots. So let's look a little bit more closely at square roots. A number r is a square root of a number x if r squared equals x. So what this is saying is, if we can find a value that, when squared, is equal to x, then that r value is a square root of the number x. Again, examples will make this much easier to see. So if we have, let's use 5. So 5 squared is equal to 25. So with this in mind then, 5 squared equals 25. Therefore we can say that 5 is a square root of 25. Another example, let's use 7. So 7 squared equals 49. Therefore, the square root of 49 is equal to 7. So 7 is a square root of 49, seeing as 7 squared equals 49. Now, we've mentioned here that 7 is a square root of 49. It's important to realize that if we're talking about a positive number, that there will be 2 square roots. So when we say the square root of 49 equals 7, we're saying that 7 times 7 equals 49, or 7 squared equals 49, which is true. But also, minus 7 times minus 7 also equals 49. So in this case, the square root of 49 is equal to positive and negative 7. So this applies to any square root. If we have a square root of a positive number, it actually has two square roots, positive and a negative. So let's use the example again of 25. So the square root of 25 is equal to positive 5 and negative 5. Or we can often write this as plus or minus 5. Okay, so that was square roots. Let's look a little bit at cubed roots. So a number r is a cubed root of a number x if r cubed is equal to x. So the definition is much like square roots, but now we're dealing with cubes. So let's stick again with our example of 5. So 5 cubed is equal to 125. 5 times 5 times 5 is 125. Therefore, the cubed root of 125 is equal to 5. Right? Now, the cube root of a positive number is always positive. So unlike with the square roots where we would have the example of the square root of 25 is equal to plus or minus 5, the cube root of 125 is equal to just positive 5. So the cube root of a positive number is just positive. The cube root of a negative number is negative. So it's also important to point out here that you can't have the square root of a negative number. It's going to be undefined. Right? This is saying what number, when multiplied by itself twice, gives you minus 25. It's not possible to multiply two numbers together and get a negative value. So it's going to be undefined. However, that's not the case when we're dealing with the cube roots. We can have cube roots of negative numbers. So let's look at this. Let's say the cubed root of of negative 125. We're saying here, what number multiplied by itself 3 times gives us negative 125? And in this case, we have minus 5. Minus 5 times minus 5 times minus 5 is going to equal minus 125. And that's not actually equal there. Apologize. I shouldn't say that's equal. Sorry. Let's see. I don't want to restart this video, so I'm going to be lazy and got a little carried away there. Right? The cubed root of minus 125 is going to be equal to minus 5. I can show you that here, which I was trying to do above. Minus 5 times minus 5 times minus 5 is equal to minus 125. Minus 5 times minus 5 is 25, times minus 5 is minus 125. Okay? Now we're going to go on and talk a little bit about higher roots, which are just roots above the cube root. So 4th root, 5th root, 6th root, moving up and up. So an expression of the form the nth root of x, where n is a natural number, is a radical. And if n is even, the expression represents only the positive roots. So let's look at an example here. Let's do the 4th root again. So do the 4th root of 16. Right? This is saying what number multiplied by itself 4 times is equal to 16. And we know that that's equal to 2. Now, seeing as n is even, so our n value here of 4 is even, we know that the expression represents only the positive root. So we could not have something like this, right? The negative 16 here would not fly. We're going to have this being undefined, right? We cannot find a number that when multiplied by itself 4 times is going to give us negative 16. It would always be equal to positive 16. However, if the n value is odd, let's try 5 here. So the fifth root of minus 32, seeing as the n value is odd, we can have the negative root represented. So the fifth root of negative 32 is going to be equal to negative 2. We can check that quickly by seeing that negative 2 to the fifth is equal to minus 32. Okay, so moving on, I'd like you to try these 7 questions here as practice, and this should give you a good understanding of just the basic idea of radicals and give you sort of the building blocks that you'll need to deal with the upcoming topics and upcoming sections.